Ladies and gentlemen, welcome to Turn Right Machine Works. My name is Keith, and we're here at the welding table, and we've got our simulated asbestos cloth on here, so we got a nice top here. We have a box here with two do-it-yourself kits that were sent in to us by GearBest. GearBest asked us if we wanted to look through their electronic section there, if we fancied something, that they would send it to us, and then we can have it to play, show, share, walk the talk, and create a video. And that's what we're doing here. Now, he's saying, okay, what did he pick? What's in that box there? Well, I remember when we were playing around with our dash insert for the Porsche. In the short of everything there, we created a drawing. We sent it to John Saunders, and then he gave us some examples of how he would go about laying it out, and then how we'd go about doing the cut paths. And two of our viewers had printing 3D printers and printed up these really nice samples to where I was actually able to see one that I gave him the wrong dimensions for the bores, and these don't fit all the way in. but besides that, I was actually able to put this in a dash. And you know, after seeing samples, not just samples of printed work, but actual samples of a file that I created and then gave it to them and had them print it, and they printed it out, and they sent it to me. You know, I'm super grateful. Thank you very much. I'm floored by the community sometimes, the generosity and all of that. So in GearBest's collection there was a 3D printer, and it's an Anet E10 aluminum frame multi-language 3D printer do-it-yourself kit. We got that in here. While I was looking around in electronics area there, I also saw a do-it-yourself digital oscilloscope kit. And so what do you need an oscilloscope kit for? Here again, early 1985 944 Porsche has got a pair of sensors on the crank. And one is for timing, and the other is for speed. And both of these sensors feed information from the magnetic pulse that they create to the DME. And to properly test the functions of these two probes here, or sensors, is with an oscilloscope. So that triggered it. Well, you know, why build one? Then you can just buy one. Probably you can get one on eBay. The whole idea is the learning experience, and the reason why I'm wanting to get into electronics just a little bit more is because there's some other things that I want to do some things with some Arduino, controlling TV coming down in front of the big bay window. So that I got my big screen and I got remote control and I can put it up out of the way. There's a lot of other things there that are going to come to play, and I would like to have a little bit more experience in it, plus the satisfaction of going ahead and building one and then going out to the Porsche and verifying it, and it's just, I live for the project. So sometimes it's all about the project and the end results afterwards. Sometimes that doesn't get played with unless it's a tool. Yeah. It's a funny thing about tools. Tools always get used, and so you know, that's what I'm looking at. It's a build it yourself tool, and no more than if I was to take and design something, cut it out on a plasma cam, and then go in and use it as a mechanical tool. So, you know, this kind of my line of thinking on that. All right, so let's go ahead and clear out this table, and let's get the box open and we'll check it out. Okay, I'm just taking it from the top here, and It looks like they gave, we got two plastics coils right here. Both of them are white. And we got some 3M sheet right there. And there's the E10 manual. Okay, and there's protection there. They wrapped it up pretty good here. Okay, by the looks of the components and the electronics right here, this is the oscilloscope kit, and looks like the instructions are in there as well. All right, this is nice. It's all in anti-static wrapping right there. All right, so we're going to take this and we're going to set this off to the side for right now. I don't know which is the front, back, or anything yet. It looks like we can just pull this right out here. Didn't really help us get anything out here. I don't know what that piece is. Okay. Got a scraper. And that looks like the top rail right here. Okay. We'll go ahead and we'll set that down here. Okay, and got a delivery slip in there, and little tube there, a USB port cable. Here's our, well, I hope it's spare parts. Okay, well, we'll take that as spare parts then, and looks like a USB and memory card that we can run it with, and some Allen wrenches and some zip ties. Okay, now let's go ahead and get to the instructions here. Okay, I found the Allen wrench. I've got you in position here so you can kind of closely see what's going on. The one little square was just one of the little square blocks that went into the end, and I popped it in and it's good. So it was just loose in the container. Okay, I undid the little zip tie that was on there, and I'm rolling this very carefully up here. I know not to race servo motors. Alright, now we have enough clearance to drop this straight down so that that one plug will clear the table over here. Okay, we turn these inside nuts vertical. That's what they say, to go ahead and put those up and down. And now we can just slide this into position here. As soon as we turn it around to the right side. Okay. Now it says to go ahead and put these two Allens into the bottom. Okay, just lightly snug until I get the other one in. I'm just doing it the same way. I'm gonna slightly get my hand in here. There we go. And tighten them up. Okay, so it said tighten these up. Okay, turn it back around. There we go. Okay, now we attach this piece here with these two 4mm screws. Okay, all right, that's tight. Okay, the next thing is the filament holder, and this is a printed part, threads and all. That's pretty cool. All right, and that goes through there like this. All right, and this side here unscrews, and our filament will be able to go on there. We don't have any spools yet. We just ordered them yesterday, so they'll be here in a couple days. All right, next part. Good morning. Last night I had to take a break from assembling this. We got the reel mounted onto there, and the next step was to go ahead and start hooking up the leads, and I was getting ready to spin this around, and I wanted to slide the tray through here. The tray cannot slide between the two servo motors. I'm going to bring you in because we're out. The servo motors are out of alignment at like a 1/4 inch in the width of this machine here. And here's a couple pictures that I just took in this position right here, and you can see the 24-inch scale setting flat, splitting the difference of the scale so that it sets by itself against the machine surface of the servo, which is the square surface. And you can see from side to side actually how much this is out. Now, I've physically looked down and made sure that the motors didn't come down and didn't contact any of the green striped trim, and those were pre-mounted onto the rails there. So, and you can see underneath the table itself where they're hitting the knobs. So we're gonna move this around. We're gonna bring the camera in here. We're gonna get you in a little closer, and we're gonna see if we can rectify or fix what needs to be fixed and adjusted, whatever needs to be adjusted, and we're going to double check over this entire machine here just to make sure that things are up to snuff. Guide rails and stuff like that. The Plasma Cam and also the X-Carve are two machines that are similar to this as far as how, I mean, they use different rack gears, and these are lead screws, and some of it's belt drive, but it all travels and is all guided by rollers and on a track and all of that. And so there's a similarity in it in all of these machines, and I'm going to go through this machine here and just making sure that everything is up to snuff. I mean, I only got 4 pages of instructions here, okay? All right. Let's bring you in and see what we can do. All right, this is a servo motor. We're looking at the back of the machine, but this is the left-hand side if you're on the front of the machine here, and the controller is going to be sitting off to this side. And this L bracket with these two bolts here, that's what holds that servo there. And this, of course, this is in the way a little bit here, but you can actually see that flex coupling there arcing, and we're not quite touching, but my scale thickness won't fit through there, but yet it passes through this side here with slop. All right, so you can physically see that the motor in relationship to the frame. Also, this L bracket right here, this passes by here, but we're interference here. So this upper part is sticking out past the frame, and this is sticking in from the frame. So those two Phillips screws there, those two Allen screws right there, we're going to loosen those up, and we're going to see if that will stress relieve the motor and let it sit down in a line. And if it cocks down in there, then I don't know if you can see let me get you twisted just a little bit here. Okay, I think we got you in position here where you got a good view of everything here. The rubber or the plastic knob here that adjusts the spring tension on the tabletop here is what comes and what is actually hitting the receiver for the electric harness right there, that plastic plug receiver. All right, now hopefully when we get to adjust this, it'll drop down and that will clear, and then you can actually see the misalignment between this shaft and this shaft right here. It's pretty obvious. We're gonna go ahead and loosen up these two screws and these two Allens that bolt to the face of the servos. Because this here, I can pass this scale by here, we're hitting here, so we can see a cocking here. We've already checked out, but we're not sitting on any of these stripes right here, which would have possibly held that up out of or off of the correct position. But this assembly here was pre-assembled before it was sent here, so I just think it just happened to be tightened down and it wasn't quite in line, or it was sitting on something, or whatever it was jigged up there. So let's go ahead and let's see if we can find the right Allen wrench, and we're gonna loosen these two things up here, and we'll take the screwdriver, and that's not even tight. Oh, look at that pivoted right there. Just it lowered it, but it still may have to. All right, we're going to loosen this up all the way here, and we're going to see about getting that down. And then we're going to take our straight edge and lay it across here. We're going to loosen the other side too. We're not going to tighten them up until we know that we're sitting stress-free between those two motors. Okay, we're going to do the same thing over here on this side. That one was fairly snug, and that one was loose. Both the top ones were real loose. Okay, we can lower that rail or adjust the screw to where the down pressure is creating down and flat, and let's just make sure we are loose here and that is down and flat there. All right, now, all right, that still will not pass by there. Dum-dum. Okay, let's we're going to go ahead and we're going to take our scale and we're going to put it across here, and those motors are perfectly level, and that table is actually really level as well. All right, we're going to take a photograph of that. All right. The couplings look relaxed now as well. I'm going to go get a little straight edge, a little one of my 3-inch scales, because then I can put it in there and I can eyeball along the side here, just to verify that those couplings are now true in line and not curved like they were before. I'm going to lightly snug up these 2 points right here. And I don't think I don't think I'm going to have to do anything with the the Allens right here right now. I think they're fine. But we still will have an interference fit down here with that screw for some reason. And we're probably going to have to check out this framing out down underneath here. It looks like I might have a bent part underneath the table there. Okay, let me slide this tray back this way here. I've got underneath here and looked at it, and I'm going to pitch this a little bit here and see if I can hold this. Is that as far as that comes out? Well, it comes out far enough. You can see that. All right. This is the knob that's hitting that, and that one is nearly hitting it over there. You see this spring, how it's not straight up and down? See how that one's kind of like oddball there? Look at this plate right here. All right. Now, I might be able to put my scale in here. See if I can do that. Okay. This is bent down. Well, let's see. We're about 450 there, and we're almost 550 there. Almost 1/8 of an inch of bend in this plate here, and then that one there. On the other side there, it's not quite as bad, but it's somewhat the same thing. All right, how it got bent, I don't know, and why it was sent to me in this condition, I don't know. Why they're, you know, maybe they needed it repaired. Okay, what I'm going to do is I'm going to pull the cross rail back off. Because I need to be able to flip this lower assembly around, and we're gonna pull this heat plate off of here, and we're gonna get underneath that subframe there, and we're gonna find out what is bent in that, and we're gonna straighten that out, reassemble it, and see if we can get this thing squared away. Okay, I've set the top frame over there. I got this kind of turned around here because I want to hold it up like this, and I need to, I'm going to go ahead and take a couple pictures of the thing here so you can clearly see. And this is the better side. I'll turn it around here too as well. All right, let me turn it around, and this is the limit switch side, which is also the controller side. Alright, so it actually looks like the subframe or the sub mount where this plate actually bolts to, that part is bent. So let's go ahead and we're going to move this in here, and we're going to go ahead and pull these spring mounts off of here. Okay, there's one. And there's two. The plug for the heat plate goes in the back. I just, hope there's no damage to the heat plate there. Alright, and our last one here. Alright, and we'll lift the heat plate off, and doesn't look like any of those screws are bent. Okay, and we'll go ahead and we'll pull our screws out of here. We're going to be secure because none of these screws are in the spare parts collection. At least I didn't recognize them. Okay, let's see. Hot zone, do not touch. Before touching, power off. Heat bed and wait at least 10 minutes. Still hot after powering off. Do not leave unattended. Keep away from children. Warning, still hot after LED goes out. Okay. Nothing looks scraped or damaged underneath there. There is a blemish right there in the center of that. I hope that's not destroyed at all. Okay, you can physically see that the bend is here and here on these off of the rail. I don't know if the rails are bent or anything, but that's 300 thousandths there, a little less than 300 thousandths, and these are almost 3/8 of an inch, 400 thousandths there, a little less than 400. So there might be a little bit of a bend in there as well, slight bend. That looks pretty flat. Good bend there, good bend there. All right, so we do have a little bend there, pretty good bends there. This side over here looks like it wasn't bent, so whatever took the impact over here. Yeah, I got all the screws loose. I had one that had an oddball head on it. In fact, I like my other screwdriver here better. The screws are pretty tight to the hole, so that's, you know, and they all line up good, so that's great. All right, now we're just going to set that there, and those bearings can just stay right there. All right, there's a good look at the plate there. A little bit down there and a little bit there. Now we're just gonna go into the our mill vise, and we're just gonna squeeze this, and we're gonna see if we can get this to lay flat again. And so hopefully we can get these two pieces perfectly flat. We can get them mounted back in here. Okay, less than a frog hair out anywhere along that plate. Wasn't bad. I had two little bends there, and then I had a mild bend in the middle from me putting the pressure on it. But they're right there. Okay. Let's see which side. Okay, it was in here just like that. I can see the bearing prints in there, so we're making sure, and that's why I did one at a time, is I just want to make sure that we don't switch them or mix them. And we're getting back exactly in the same location. Trash man's here. Empty our dumpster. Okay, we'll get the rest of the screws in on this side here, and then we're going to pull that side apart. Alrighty. Getting the other one off of here. Okay, and okay, now this is flat over here to where it's touching here, but it's hollow in the middle and down over here. Alright, we're going to go do the same thing with this one. Okay, the same thing on this side here. About one frog hair in there somewhere. Alright, and there's where the bearings went down, and this lines up with that bolt pattern there. I'm just bringing these down just to where they're touching. We got to square up this platform because you want all these bearings in this piece here to actually be square to each other, and we're going to do that with a square. Alright, now we need to square it. So we're going to get a square to go along this edge and across this face here, and we're going to double check it along this face and along here, making sure that we got both of these in line with each other right here, so that that pattern will be square, and then the plate should mount right back up to it with no problem, with the right spring tension and all of that. Alright. Sip of our hot coffee. So, you know, we just went and got it after the trash man came. Alright, we got about 100 thousandths there. We're gonna pull that back a little bit right there. That looks pretty square. Let's check it back in this direction here as well. And that matching up pretty good. All right, let's tighten up. We're going to tighten that very first one right here. These are really the ones that control the alignment. These 6 right here. These actually hold the bearing down to the plate, but you want those as well, otherwise they would somewhat twist that bearing. Let's double check this again. Frog hair in there. And I don't see it there. Alright, I'm going to consider that square. If we have a problem with it, we can readjust it to suit the mounting plate, but now I just want to double check here. We got 375, 375, 375, about 380. All right, this is now level. It travels easy. All right, this belt's still probably not tensioned quite tight enough compared to the other ones that are there, but that's just, oh, that's why, because that's not even tight over there. All right, let's turn it around. Okay, let's play with that. If it needs to be tighter than that, we'll add it, but I think that's more than sufficient. Has enough play and flex. All right, one other thing I want to just double check while we're here, and I don't know what it was supposed. See, these are plastic printed bearings out here, or guides, and okay, how close are these two guides to each other? Pretty close to 7 inches there, and we're about 6 inches, 987 or so. So it's a little tiny bit narrower here than it is down there. That's not loose. I mean, that's not tight. That's not tight. Okay. That's not tight. You know, I probably could take a measurement from here to here to actually see if those will. Okay, that does sound better. Feels better. Let's see what we got now. Just if we stress relieve those, that of course be about 7.5. and we got like 7, 1, or 2. So now they're closer in line, and actually they kind of did. They. All right, for right now, I'm going to leave that as well, and I'm going to go ahead and snug this up here. Well, let's just see if we can answer our own question right here. Let's see if I can get. I mean, this is going off an extrusion here, so we got 2 inches, 940. Two inches 950. Two inches 945. I'm just eyeballing this as square as I can right here on that side here. Okay, 2 inches 875. 2 inches 873. All right, so it's over this way a little bit, but it's pretty square to the frame that we're mounting there. We could actually shift it over this way here a little bit if we wanted to, and kind of gauge. Let's just see what our clearance is before we actually do any kind of moving around with it. All right. Now let's go ahead and let's bolt our table back on here. All right, and we're just hoping that damage right there. I'm going to get a magnifying glass just to see if I don't see any, because there's bars, and I just want to make sure that there's clearance between any of the brass contact, and we just don't want that to ground out on itself. All right, Inspector Clouseau, what do you see? Well, I see a little spot there, or not. Let me get my little scribe here, or a pen. Okay, let's get the light right here. Now there's actually one little chunk missing right out of here, but I think that might be bridging there. Okay. It'd be a shame if it doesn't work. I don't think a printer is going to be any good without a hot plate, but there was a piece that was folded over, and I got that from touching 2 of the bars, but one of the bands going across there, really pretty hard to see if it's actually broke or if it's going to make contact. Well, there's only one way to find out, and that's put it together and see, and if it doesn't, then we'll see if they'll send us another hot plate.
Okay, and the last one. The springs look pretty straight so far. Alright, and got some fat fingers today. Okay. Yeah, the springs look much better. All around. Yep. Okay. We could travel this around or take a height gauge off of here, and then we can level this off here, or we could take a measure down with our depth. But I'm happy with that right now, that it is more square than it was. And of course, what did we do? We put the plug on the wrong side. Alright. That's what you get for flipping it around.
All right, back to where we were with the plate facing the right way. Okay, front of the machine, back of the machine. Okay, now we're going to go ahead and we're going to lower our bridge back down on here, and we're going to see if we have a problem with the hitting of these screws. And there we go, that's down. We're going to make sure all of these green things are cut back plenty so that this thing sits down on here. All right, because this right here. All right, that's not touching. That's not touching. That one's not touching. That one's not touching. That front's clear, that front's clear. That's clear. That's clear. Okay, this is just some Tef gel. Just putting a little teeny bit on that fastener and just a little teeny bit on this one here. It eliminates corrosion on most marine applicated stuff, but this also will help in this situation here as far as the aluminum and the steel. All right, that one's in there tight. That feels a lot better. All right, moment of test here. Okay, and it clears over the top of those with no problem. Wonder if I can still get a little bit more clearance if I let this go down here a little bit more. Tighten those up pretty good. Okay, do the same thing over. I just want to make sure that these are sitting down and square against the top of that frame there, and then they'll be as close to being the same height and everything else. All right, now let's go ahead and just take a square across here and verify they are flat. All right, now my tray is here, and it's now sitting proud of this. Remember the first one there, it was actually bent. That tray was bent down 200 thousandths. Now I think we can advance from where we wanted to be last night, but we're also going to be checking these rollers. I got tight on that side, tight on this side, tight on that one. This one here is a little loose. This one isn't even touching in here. It's way far away. And this one here, this one's loose. Okay, I can... okay, we're probably going to have to zero out our rail to double check any of those. Okay, we went ahead and got our meter here because, you know, we just had a brainstorm. Now we know that the two on the outside, I believe, were plus, and two on the outside over here were minus, and two inside weren't marked, and I think that's thermostat. So to create the power, you need to have a completed circle between negative and positive. So if we were worried about that break, we should have, we got beep in there. We're going to test the two positive, we got contact there. 2 negative, we got contact there. The negative to the positive, and there again. All right. And we have nothing in the middle, and the middle is not connecting with any of the others. We've tested. I think we've tested that. Okay. Okay. Measuring from the top of these motors surfaces to the frame that the bearing mounts on here, I've got 4 inches 40 thousandths. I just spun the individual lead screw until it adjusted the height, so we're perfectly square here, and we actually could measure down now from this rail down to the tabletop, and we could get that as well. But basically, the reason why we set this up here is we want to get the feel of these 2 rollers and these 2 rollers, and that should be making contact now. We know that this one here we found loose, and this one here is just, it's totally backed out from there. So we're gonna go grab a little wrench. Okay, I got the right wrench that I can reach in over here and grab the nut, and I have the Allen wrench. This roller right here that's spinning freely and has got plenty of air clearance between it and the rail is the one I'm going to adjust here, and go ahead and loosen it up. Okay, and then I can bring it right in. I can still spin it. Okay. I have to force it to spin, but it's there with minimum amount of pressure. All right, I like that. All right, now we're going to do the same thing with the other side. All right, and I can see that one, it's just wicked loose right there. Okay, and hold that in against the rail. Alright, I like that. This one up here is not, I'm going to loosen this one up and see if these look like they're not adjustable. These actually look like there's no slide to those at all. Okay, but that does feel, that's got a little tension on it now. All right, those are great. This one here doesn't feel like it has anything on it, but it's got zip ties on here, so we're about ready to break loose those zip ties. Now let's change this around to the front. All right, we're finally ready to break our carriage loose here, and I'm just going to snip the zip ties here. Find the right spot to clip them so I'm not damaging anything. Okay, and I guess this is already preset as far as that tension going on there. And all 3 of these rollers feel good, like I would expect them to. All right, now we can get back to one of the 4 pages of instructions to figure out what we're going to be doing here. So I think the next step is actually install the filament holder rod. We have got to cut this little zip tie that's holding all of our leads together, because this is the next assembly that they want us to put on there. And we're just going to separate all of these leads so that we're not going to be a spider web nest here. This actually comes out of the middle, and there we go, all the way back to the back. And that's the thing, they don't give us a picture of this thing 100% wired up, so we got to guess at the path that these go to. Alright, part 6. We're only on part 6 of this instruction manual. Okay. Please tighten up the two 4mm 8 screws. I think that's what they're talking about, these two right in here, on the two sides. Then tighten the black jack screw up after the installation of the heating tube and thermistor. Okay, so here's the heating tube and the thermistor is that little lead right there, and they fit right in here. There's that black jack screw, okay, and the black jack screw was missing. I actually had to take it out of the spare parts here. So I know that this is the operation here, and I'm just gonna I might have put that down and just, okay, there we go. Okay, that would go in there like that, and then the fan has to go on here like this. So you really can't do any adjusting or anything else on this head up and down. And why am I concerned? Because this was already mounted here, but while I was checking all the other things, I'm looking at it going, okay, from here down to the hot plate is 1 inch, and from here to where that triggers off the micro switch for the down travel, looks like it's pretty darn close to that inch. So let's bring our tape. Let's see. Okay, it does. We can go down below. Now I'm just taking the lead screws here and I'm turning them simultaneously, and I can feel when they're timed with each other, and I'm just listening for that little click on the micro switch there. Kind of hard with the fan going. There, I heard it. Okay, now we slide this plate, and it looks like we're hanging down. I can't quite see the tip of the nozzle past this plate, and this is about 100,000 thick, but we're hanging down every bit of that. All right. Okay, that screws. I was wondering if that was threaded in there or what. Okay, now where to set this? See, there's no operation manual or anything else, but on the back here you got to kind of like read between the lines. If the nozzle is too close to the hotbed, there will be no room for filament to come out of the extruder, and if the hole is at the top of the nozzle is always blocked, the filament cannot come through as well. And that had to do with a question about extrusion, not getting plastic to come out. Okay, so we know that it has to be at least up somewhat, triggering or whatever, but we're about 50-60 thousandths above there right now. What I am going to do is go ahead and make sure that we should be clearing all the way across, and all the way across there, all the way across there. Okay, my best guesstimate is that I'm not going to hit if that micro switch comes down in there, and I'm not going to super tighten that. Okay, I'm just bringing it up out of the way a little bit here. I don't know where it has to be to start it. I will exactly measure down again, set those exactly even when I energize this thing. Alright, now let's go ahead and let's put in our components here that it tells us we need to put in here. Okay, and then it tells us to lock this down. Okay, and then this bolts right to there. With these two screws. Now, I didn't know which way to actually run this or route this. I had to look online for a couple pictures, and it kind of shows it here, and I know that it goes through this little plastic eye here. Now, I think you have to run it all the way over here, and then we'll just make sure that that has enough right there, and we're going to loosen, we're going to put that into that eye right there. Alright, so we're going to break that screw loose. Speaking of screw loose, as I was sitting here, I'm staring across, and this screw right here on that nut is loose. It's big time loose. I'm going to have to go through and just check every screw on here. Okay, we've got that lead situated there, and now we've got to plug in our other units and our limit switches. And before we get going, I went ahead and set up my meter here, and I'm triggering it manually, but I'm going to go ahead and roll this down, and I have this set up here, and I just want to make sure that nothing's going to hit the table for the initial startup. Okay, and we're off the table about 50 thousandths or so. Okay, I didn't find any other further instructions. I double checked in the box. The only thing that was in there was the packing slip from GearBest. That was in the bottom. So they had to put that in there and then pack everything else that's in the box there. So this has got to be the only manual. And of course, to the last page of the manual, and I still have parts. Now I know that this tube probably plugs into there, goes around here and plugs into there, and that's what I'm going to do right now. I'm just going to cut that. So that's probably as simple as that is. But there's no quick start guide or anything else to this thing. So I'm just going to be left to discover it myself. I was checking out, it doesn't even talk about inserting the filament, and it does have a push button over there, and it kind of looks chinky here on the screw. I kind of like tightened up that screw and tested it, and then it has to run loose so that thing will pivot. I'm just trying to work out some of this curve here. Okay, and those just push in and lock. And I think on the picture it just comes around here so that as it's going up or down, it's always around the outside like that. Alright, and right now for testing, we only have we have plastic here, and I think they gave us both things are plastic. Now we did a little, not a whole bunch, but recommended filament was plastic. Okay, but you can run ABS, plastic, HIPS, and all of that. Now plastic's a little temperamental about the heating and everything else, so we went ahead and we picked ourselves up an infrared thermometer, and this one here is a newbie, and we are a newbie, so I thought it was pretty cool. So anyway, I got that so that I can make sure, and we are going to be testing this plate, making sure it gets hot before I put that film on it. I believe that sheet of film, and that goes on there, which I'm just left up to do that myself. There's no film here, but in a couple of these pictures here, like that one, looks like the film's on there. Looks like the film's on it in that one there. And that's, looks like it's on it in that one as well. Okay, but I don't want to put it on if we have a faulty plate, because then they can send us a new one and they don't have to send us the filament also, or the not filament, the covering. All right, we're satisfied with that. Let's go ahead. We're going to hook up the rest of our leads. Okay, and the last thing that we have, we put all of our connections on, and we put our wires all out of the way, and we cycle that thing so we know that nothing's getting caught right now. I don't want to zip tie them down solid down to the frame. That's what my plan is, so that they stay put. And anyway, this is the power cable they gave me with this unit here, and this is a 250 volt plug, and of course it's got the standard receiver in the end. Now I don't have that in my shop there, but I do have the same plug going for the 110, and on the side of the controller here, 110, 220, and I switched it over already to 110, made sure I'm in the right position, and I'm going to go ahead, I'm going to go around the other side because I need to see the switch too as well. Okay, and the power switch is off at this time. Alright, we're engaged there. We're plugged in. Alright. Just want to get my phone ready in case anything funky happens. And alright. On and off on the back. I don't know what the knob is for, and we have a reset. Alright, and all we have is troubleshooting questions on the back, and that's all we got to it. Now, I went ahead and, okay, I haven't. It has a USB card that you can program this mini card. And the mini card, I'm just going to stick it in here. And we have the USB cable to hook up and run the other software, and I might get that on there, and it might actually have to be on the computer. And so we'll be getting in there as well. This is just my area that I wanted to go ahead and assemble it. I'm going to power it up and just see what we have, and if the thing has any automatic whatever. Here we go. .3D printer. Printer ready. Okay, I knew if I played with it enough. Actually, this is not just a dial. This is also a push button, and then you can rotate it, and then you can go down. And I hit prepare, so I hit preheat and preheat for plastic, and then you can preheat for ABS. So I did that, and now with my my newbie gun, my plate is heating up. We've got about 130 or so developing there, and up on the actual nozzle, I'm getting about 100, and it bounces around 140, 150 degrees. So it is prepping itself up. And I can feel the warmth by touch too as well, but I'm glad I have the heat gun here. And I'm seeing how much it changes from outside all the way around to inside. And actually on that plug, that when I plugged in the hot plate, the plug only had 2 connections on the outside, and then the thermostat on the inside there. So and it's reading what I got in here on the plate, and I think it's in Celsius here. So it's reading, the head is about 201 Celsius, and and the base plate is 50 Celsius, so I was reading about 120 or so. Yeah, 117, 124. All right. Okay, move axis. Move 1 millimeter. Okay, move x-axis. All right, look at that, huh? Okay, for I don't know, because that was where it was at 0. So, all right, so it's dialing in there. Okay, let's go Y. All right, that's going. All right, Z, up. All right, so far I can control everything, and I think that was just because that was at 0, and extruder. Okay, I can see the extruder advancing. Okay, just finished dinner. Had some tacos, really good. One of my favorite meals. We swung by the plasma table and we grabbed our 3D printed part that one of our viewers sent in to us, and I wanted to place that on here in respect to size of this printer, and it's one of the reasons why I chose this printer. And it's because it's 220 by 270 by 300 millimeters, which means 8 and 11/16 by 10 and 5/8 by 11 and 11/16. So it'll almost do a foot high, a little bit over 10 and a half, and almost 8 3/4 on the depth. So it's a pretty good size printer, and that's why I chose it. Now I may get some kind of a enclosure to where I can still, it'll be in there, so it just dust protected. I think it is important for printing to be clean and not have anything floating around on it, and also being controlled in the temperature. Now we've ran it, and the hot plate is getting hot. We put on our black surface here. We're happy with it. We took a blade and really trimmed it really nice. It did have a couple crinkles in it, but we're going to live with it there. And we're happy with it. It was, well, hey, let's face it. Okay, I got another Chinese challenge. Not that it came from China that way, and from the little scarring, the one little broken piece here, some things that were tweaked out of place, and the little mishaps that you saw us go through to reassure that this was doing what it was supposed to be doing. So it's just those 6 screws you got to put in, and the thing's all together, right? There's only 4 pages to this. There is a troubleshooting section on the back here. And after we turned on and we found out that you can, there's no easy step guide. I mean, the easy step guide would be just as long as this manual right here. The easy step guide for a cell phone is at least that big, right? Regardless, okay, you turn it on and you push the button and you can hit all your parameters. You can you can move it around manually by the controller, everything. You can almost do everything that my plasma cam controller can do as far as moving the thing around, which is excellent. And also we can go ahead and click the button. Let me turn it on. And we can tell the thing to go home. And now that we know where its home location is, we can go ahead and drop down our nozzle just that little bit more, because we're going to have to come up and we're going to have to set plate height to create our parts in relationship to that plate. And then we will fine trim off this plate is fully adjustable, and everything seems to be really operating fine. Performance of this machine is yet to be seen, but I'm happy that I have it functioning. I have the plate is warming. I was worried about that little scar that was on the bottom of that, and I have moved it all around, and I seem to be holding. Of course, I haven't put an indicator on it yet, and you know me, I will put an indicator on there, and then I'll be able to adjust by these spring adjustments here, this table in relationship to the travel of X and Y. And so anyway, this is basically telling you, and it always gives you a degrees of what your tip is, what your plate is, and your fan area. So you push the button and it gives you screen information. So you got prepare, and you push that and it gives you the preheat. You go down to position and you can go move axis, and the one I was looking for at the bottom of that is auto home. So you push that and then the printer automatically goes to its home position. And I'll be putting my zip ties on here real shortly, and I'm going to be moving it into the X-Carve room, where I'm gonna have a home base for it, and then keep it protected and in there, so that I can run the computer program that I run the X-Carve with. I'm gonna run this one as well, and we're gonna download the Cura, and we're gonna check that out. So that'll be the host that will run it. But anyway, you can see the tip now is going to be coming down, and it's outside the plate, and that means that even when it comes down and hits that safety switch and locates 0, it's out over the plate and over into the outside. So it's outside your X and Y, and but I do have it set higher than a table, and I know I'm going to have to come down, and you have to have a certain amount of distance off of the top of the table, but you need to know where that is and be able to get to that table top as well. Just common sense tells me that needs to be done. And control. So you got disable steppers, you got cool down, and then you got nozzle, and you got bed settings, which I'll probably learn about that as well. And then configuration, you got that, and it's got temperature, motion, store memory, load memory. You do have a memory card, fits in this USB port. You can program it, and then you can just put that in, so you don't actually have to have this connected to a computer. But they do give you the USB port cable, and I'm going to be plugging that in, and we're gonna find out everything all about it. Now, I do have this filament, and maybe tomorrow I'll get that in there. Maybe I'll see after I've got the Cura program to give it a test. So I'm sure that I was just sent a return or something like that. And hey, they watch my videos. They know what I can do, right? Huh? Look at that grinder. So I'm not actually saying that Anet is a bad machine because I've yet to actually test it and function. It does run smooth, and as far as if it was just those 6 screws and those wire plugs there, you could actually put this thing together in probably 30 minutes. Plug into your computer and download a thing, and you'd be printing within an hour of receiving this thing. You know, make sure that you specify the right cord and other things like that. Also, at the same time you get a 3D printer, you wanna order some material so you can put the spool up there and connect it up there. Tomorrow we'll be putting this into the X-Carve room. We're gonna find a nice clean space and set it up so that we don't have to be moving it around, and we'll kind of plan out an enclosure that we're gonna want to put it in. We know we're not gonna run it open like this. A lot of them have got enclosed booths on them and stuff like that, and I chose this for the size, and I'll make the booth whatever. We'll get hooked up with the Cura program in the computer, and we'll see about connecting that up. And we got the USB port there. We got a couple strands of plastic material we can possibly put in, create the G code, and we can put it in there, and we can make a couple practice runs by putting one into the card and one directly through USB, because we want to be able to do both of those. So this is the Anet E10 manual. I say Anet because you know, I grew up with Anet Funicello. How many of you remember her? Those of you that don't, she was a pretty hot beach babe back in the day. So if I'm mispronouncing that, I have my reasons. So we're going to be taking her into the X-Carve room there. All right. Until next time, get her done. All right. I've got the links for this E10 3D printer and also the oscilloscope that I picked up from GearBest, and I put those in the description. And feel free to click on those and pick one up if you want one of these quick 6-bolt assemblies. Actually, you know, I got a Chinese challenge here, and I don't know where along the way or whatever it was decided to give me this one here. But they probably watch my videos and they kind of know what I can handle and what I can't. And so, you know, it's functioning and it's doing what it's supposed to be doing so far. Let's see if I'm going to be able to do what I'm supposed to do to make it do what it's supposed to do. Okay, I believe I'm ready to try it again. Now, I ran it once already, and I thought I had too much pressure down there, and also the plastic was in on top of the lip, so it wasn't feeding down into the cup. We got it to feed down in the cup because I know now it's stuck down there, so we have melted a little bit of plastic. All right, so here we go. We're going to go ahead and we're going to tell it to print from SD card. And Rocktopus G code. Okay, it's heating up now. Alright, looks like it's ready to go. I see it's starting the plastic. Woohoo! Alright, hey, let's zoom you in here. Alright, this is going to be like 54 minutes or so. And this is going to be something to see for my first time. At least I got the headset right, and I do have plastic coming out of the nozzle, so I am making headway here. I'll probably have to order another one of those black sheets on there just because I scored that one up already. It did have a couple dings in it, but we're going to push it as long as we're learning, and we'll just have to see. How we're doing, if everything is getting hot enough and staying the right temperature and all of that. I do see stuff mixing around. Moving around, so I wonder if my table is hot enough. It's only like 2% printed, but I'm already starting to peel some of that stuff up there. Yeah, it's like my plastic isn't sticking to this plate. It's moving all over the place. Okay, we're telling it to go auto home. See what I mean? We're not sticking. I'm not sticking to that that material there. But we are sticking to the nozzle. Because the nozzle is getting hot enough, and okay, now we're going to read into our troubleshooting now. Okay, we started playing with our flows and our temperatures, and we're starting to get something that looks like it's sticking and it's staying in place. We increased our flow of plastic also. Here we are again at 2%. This is a lot better than it was the last time. I'm running, my temperature's reading at about 176 degrees or so. It says the nozzle temperature is about 210. And plastic's supposed to be usually about 180 to 200. ABS printing temperature is 210 to 240. I don't know. It's definitely doing something different and it's staying down, so we're going to let it run. I don't know if we're running too high above our realm there, but so far it's looking pretty neat. Definitely gonna have that little octopus engraved into that black stuff right there. So if it melts and rolls over there, I guess we got it too hot. All right, so but it's telling us that we're about 4% done with the printing, so it's got a ways to go. This is our first part printing. We've had 3 or 4 scraps already just on the first layer, just to peeling off of the deck. So we started getting temperatures and speeds closer to getting something that actually sticks to the table. So we're doing pretty good on something, I guess.
What's it making?
It's making that octopus that's on the screen over there.
Okay. It's gonna be 3D?
Yep. It starts out flat and it just prints as it goes up. And see see the octopus? He's going like this. Not on there, but you can see it on the screen.
No.
The plastic is being fed in here, travels through here, melts at the nozzle, and then squirts out the end.
And that's the white.
And that's the white, yeah.
It'll go all the way to the white on the outside?
No, it'll only do the shape. I don't know why I did that. It was like just an outline or whatever.
Now I can see it on here.
Yeah. Oh. It'll be up in. He'll be holding this up in the air. One of his legs is actually going to be up. It's that one that's yeah.
Don't touch it.
I had 3 or 4 flubs. When it flubs and it doesn't melt right, it makes like a white spider web. So I got white spider web pieces laying around here somewhere.
I see 'em.
And I had the nozzle, and I put scratches in the board. I did all kinds. I did everything you could do, probably wrong right off the bat. Okay, this is about 26% through. As far as the timing going. We are printing. How cool. Of course, this was the all pre-programmed part here, or actually figure, which is going to be pretty cool. White is the only thing that I have to play with right now, and I couldn't wait for my new rolls. It was Friday. I don't know when they're going to get here. I got 3 big spools of color, and but I got a few things to play with here, and here we had our scraps, and we're learning how to adjust the table to the cutter spout, and that's what the spring-loaded nuts are for, so that you can get that set and dialed in. It's almost a flashlight and an eyeball type of setting. Okay, this moved your camera down so that you could look underneath and see the printer head itself building up on the top of the octopus's head and one of his tentacles there. Pretty cool. About 80% right now complete. Now I'm going to have to look and learn on the settings and everything else to see how I can make this more solid and things like this. So a lot to learn about printing, but I'm happy that within 3 or 4 attempts there I actually got something that is taking shape and is holding together. So can't wait to see it done. Okay, we reprogrammed with a little bit of different parameters because we did cut out our first little octopus, and we're going to change locations of where we're going to print it. Okay, we're watching the second printing, and of course I jacked up shell thickness to 1 millimeter and fill density 50%, and the print speed I got it up to 50. I'm printing a little bit high on the temperature for this. I'm printing like 210 or so. And we also added a skirt around the outside edge, and you notice we moved our printing to the front part of the table there. So this is about 21% through the process on this second printing that we're having some kind of success on. It's looking pretty nice. We can't wait. We'll see how it goes. Alright, we just shut everything down. We just peeled this up so that we could turn it and face it towards you. There's our very first one. Here's our second one with our changes in our settings. We just made it thicker shell. We gave the density, we increased the density from 20 to 50, and we did change the filament size, which wasn't the right thickness to actually put in there. That was by accident, but it went through the program. It was already started by the time I finished it, but we didn't have any jamming or any stripping of the filament with the drive gear or anything, so it happened to work out. I'll just make sure I change it. But the you can see now that the definition on the hand is really there, and you can see the webbing is really getting a lot tighter. It's becoming more solid. I practice because I've noticed the setting to put the skirt around here, and then you could trim the skirt if you want, but it's also easier to go ahead and get underneath there and peel that off of there. And so basically 4 attempts, and I'm on my way to printing, 3D printing. Okay, last night I went in after we got this thing printing, and we did the 2 small figures. I went ahead and got on the internet and read a few forums on flow rate, and I made a few adjustments. We're printing speed now at 90 mm's, and temperature, we're printing this about 210. Was recommended on the literature for the plastic material here. Bed temperature, we got about 70 Celsius, and our diameter is 1.76 on that, and we got the flow at 100%, and we're really flowing really nice without any skipping or popping in on the material. The layer height we set at 0.30 millimeters, and shell thickness we're going to be printing at 1 millimeter. And I think what we said on the advanced here, nozzle size, we set that as a 0.4. That's what we have here. Retraction speed, distance, layer thickness 0.3 millimeters. And we basically gave it a travel speed of 90 millimeters a second. With the free travel is 150, but the actual printing speed we set at 90 millimeters a second. This is doing a brim. Brim is a little layer that's going to sit at the base of the creature here, and we did it on our second one there, and it was a lot easier to get the thing off, and then it can be cut off afterwards. All right, we'll come back to this when we get some mass built up. All right. Well, we're we're out of plastic already. We learned something. I mean, we learned all the way along this whole process here. We're learning, and we've made a few mistakes, and they're just kind of silly mistakes. We started off, and I kind of just ran the program default settings and everything else right into this thing, and we printed this out here, and but in doing that, I had missed setting the height of the table, so we came in hard and we rubbed hard, and so we created a little bit of print there. Then we restarted. We went ahead and manually set our table so that the nozzle was just above it, which that could have been something that was put in the instructions or something on the quick start method to get started here, because not everything was set up exactly. For somebody being ignorant of printing altogether. All right. Besides that, we figured it out. I mean, we figured out what needed to be done with the machine, right? So anyway, then we went ahead and we found out that you can actually put a brim, is what they call that, like a brim on a hat, and so we printed off this little dude here last night, and it was really cool. We were a little bit slow on our feed there, and we increased our density. So we increased the density and caused it to make it more solid than this one here, and we did real good. And then on this next one here, which was actually this next one here, we still had the rim, and we were getting down towards the end, and I know for a fact that we wouldn't have made it through there. So I picked a spot there, and I says pause. So I pulled out the tube, and I changed out the filament, and in doing so, I must have moved something, because when it came back down, it was roughly about 100 thousandths off track to one side, and it printed a level there, and I go start over. So we pulled this off of here, and we put in the other fresh roll of plastic that was given to us as demo plastic for the machine here, and we were able to do this. Now, I got into reading, like anything else that I do, it's it's all or nothing. So I said, hey, let's do a little. This was after I'm editing the beginning of this video and everything, and let's take a break, and let's just go in and punch in settings for speeds and feeds on plastic printing. And so it came into forums, and so I got down to about the fourth forum, and what I really learned, and I actually printed out the speed and extrusion width, layer height, and printing speeds in relationship to how much flow you got out there. I learned that every machine is going to have a flat out amount of flow that's possible on a machine. That's it. The nozzle size and the constant feed is going to only flow. So for the material, it's only going to flow at a certain rate. Everything else is adjusted to match that rate and the quality that you want. So I can already tell on this one here, and I increase my speeds and everything else, because you can go with a layer height of 0.3 and extrusion width of 0.5, and your extrusion speed, meaning the amount that it would come out. And I was also on the forum, it told you how to go ahead and set it so that you could double check it. I didn't, but he said most likely it would be 13.5, and I kind of went on that basis there. And but this was settings for ABS, and of course I'm using plastic. So it just a little bit of difference between the two. I learning that. The thing is the inside webbing, I could have kept the high speed, and then when it come to the outside, I could have slowed that down a little bit, and it would have given me a better finish on the outside, I believe. And that'll be my next test. But I'm ready to move on to new shapes and stuff like this. This figurine is pretty cool, and it's rocking, and rocktopus is what they call it. So in a very short time, I'm able to create 3D printing, which is pretty cool. Now I'm going to go ahead and as I'm progressing on the quality of printing, I want to also go ahead and start introducing myself into creating my own drawings that I've already created, my wipers and some other things like that, and then be able to transfer those in, boom, boom, and be able to print these, and so on. So anyway, regardless of what I had to do to get this thing to run, the machine has let me get into the printing mode, and I think it's going to be, I'm going to be happy with this printer. We'll just have to keep playing with it and keep you informed, and we will honestly let you know how things are going. And I'm looking at these printed parts here that on the machine itself, and when I reach the quality that these bearing, these rod supports here, that breather nozzle there, and there's a couple other things on their machine here. The roller that they made with the printing machine, which, you know, that says a lot. You saw me measure those rods and all of that. The accuracy's in there. It's pretty cool that thread actually fits and feels pretty good. That's better than some turn threads that I've felt. All right. Anyway, interested in one of these machines, click on to my description. I've got it in there, and also the oscilloscope. We'll be playing with that as well. All right, until next time, get her done. Ta-da!